Precalculus chapter 6.4 exercises 23 through 34. In this video lesson we're going to be going over these odd number problems in this set, and we're going to start with problem 23. In exercise 23 through 26, polar coordinates of point P are given. Find all of its polar coordinates. So we're given a single polar coordinate here, in this case radius of 2, angle of pi over 6, and what that looks like, I'm going to draw over here in the upper right, is we have an angle here with its initial side along the x-axis, and we are rotating in a counterclockwise direction pi over 6 radians to a distance of 2 outside. So this is our polar coordinate pair, 2 comma pi over 6. Well, what we're doing in this case is we're trying to find all polar coordinates. Well, why do we have more than this single polar coordinate? Well, the reason is this: because we can get to the same place on a coordinate plane by rotating another full rotation. So if we rotate an angle of 2 pi beyond what we had here, which was pi over 6, what that means is that another angle that would qualify would be 2 comma, well, we'll have pi over 6 plus 2 pi, which is going to be 13 pi over 6. But what we're trying to do in the case of these problems is to write an expression that describes all of its polar coordinates in a domain from greater than negative infinity to less than infinity. Alright, so let's work that out. Well, what we're going to have is we write the original polar coordinate pair, which starts with radius of 2, and we have pi over 6, and what we're going to do is rotate another 2 pi radians, which will be a full rotation, times what we call n. And in this case, n is any integer value. So in other words, whatever we substitute in for n, as long as it's integer value, 0, negative 15, 73,000, whatever it is going to be a qualified polar coordinate that would mirror this initial location. And there is yet another way of explaining the same thing, and that would be if we rotated another 180 degrees from our initial ray, and if we rotate another 180 degrees, we would be over here opposite on the unit circle of pi over 6, which is going to be 7 pi over 6. Well, what that's going to do for us is, if we go to 7 pi over 6, we would have, to be our original place, we'd have a radius of negative 2. So this would be a coordinate pair, a polar coordinate pair of negative 2 comma 7 pi over 6. That would be this point, we would say right over here. It's not proportionately drawn, but I hope you get the idea. It'd be like an opposite the origin of the original polar coordinate pair, 2 comma pi over 6. So for this one, we would say and also negative 2 comma 7 pi over 6, and we would have plus n times 2 pi. Now sometimes you'll see this written as 2n pi or 2 pi n. So I've seen this done different ways, and so these two polar coordinate pairs written with the n would describe all of the polar coordinates for this point P. Next, we'll go to problem 25, next algebra problem. Okay, we have the same type of principle, but this time we are in degrees. So in degrees, I'm going to just draw a sketch like I did over in problem 23. So we have this sketch, and we have negative 20 degrees. So negative 20 degrees is going to be right, our initial side is to the right like this, and negative 20 degrees is going to look something like this direction. So I'll put negative 20 degrees right here, and right over here is going to be our polar coordinate pair 1.5 comma 20 degrees, or negative 20 degrees. So what we're going to have for all of the polar coordinates, it's going to be, again, just like problem 23, 1.5 comma negative 20 degrees, and we're going to have plus, we're going to have 360 degrees is what's going to take. So if we take 360 degrees, we'll come right around to its original position like this. So we'll say plus n times 360 degrees. And we have, again, as in problem 23, n is any integer value. And also, we can take a 180 degree rotation from negative 20 degrees. So here we are, 180 degrees. So about to right here. And coming the other direction, we would go like this. And I didn't draw that very straight, but let me see if I can make it look a little bit straighter. Yeah, it's a little better. Okay, so we have is right over here the coordinate pair negative 1.5 comma negative 20 plus 180 is going to be 160 degrees. So actually that's going to be plus 1.5, but we get to the original place by making it negative 1.5. So the other polar coordinate pair is going to be negative 1.5 comma 160 degrees, and it's going to be plus n times 360 degrees. And that's going to be our answer to all polar coordinates. Okay, we'll get to our next odd number problem, and this is a new set. In exercise 27 through 30, rectangular coordinates of point P are given. Use an algebraic method and approximate exact solution values with a calculator when appropriate to find all polar coordinates P that satisfy this value. So what we're looking first is polar coordinates that satisfy theta between 0 and 2 pi. So, and we have P is equal to 1, 1. So we come over here and we have point P is 1, 1. Now, I hope you recognize that's going to be in this relative location to the XY coordinate plane. And if we have a point here, 1, 1, what we have is an x value, or an adjacent side, equals 1. We have an opposite side equal to 1 also. And we have an angle here of, I hope you recognize that, the angle is going to be pi over 4. So really what we have for part A is this. We're looking for the polar coordinate that mimics this rectangular coordinate. So that's going to be the polar coordinate pair. We look for the distance here. What is going to be the distance? That's going to be our hypotenuse. So what we get is our distance formula, and our distance formula is going to be our magnitude. Well, if this is a vector, we'd call this a magnitude. We'll just call this a hypotenuse. It's going to be the square root of the opposite and adjacent. So square root of 1 squared plus 1 squared equals square root of 2. So square root of 2 is going to be our radius. And our angle is going to be pi over 4. Now we are interested in finding any other values of angle between 0 and 2 pi that would qualify. And for that, if we rotated another 180 degrees down to where I'm showing now, and we get right down here, we would get to 5 pi over 4. But if we go to 5 pi over 4, our radius is going to be negative square root of 2. So negative square root of 2, comma, 5 pi over 4. So it's making that pi rotation, or in degrees, 180 degrees rotation, that makes that work out. Now we have part B here for between negative pi and pi. Well, for part B, we would certainly have this pi over 4 would be retained. So we would have square root of 2, comma, pi over 4. And then, would we be able to use this negative square root of 2, comma, 5 pi over 4? No, because that is greater than pi. So what we're going to do instead is go the opposite direction. I'm going to do this in red. We have to go the opposite direction like this to get to the same place. And what that's going to be is pi over 4 minus 4 pi over 4. So what we're going to have for this one is negative square root of 2, comma, negative 3 pi over 4. So that's what the answer to part B is going to be, between negative pi and pi. And the last thing we're going to look at is part C. In part C, we're interested between 0 and 4 pi. So for this one, we're going to retain the first two. So I'm going to just write down square root of 2, comma, pi over 4. And then we have also negative square root of 2, comma, 5 pi over 4. So what we're going to do is we're going to take our 5 pi over 4 and add to that 180 degrees. And what's going to be 180 degrees, or pi, plus that? What we're going to have is, we're going to have square root of 2. Okay, again, we're coming around one more time, and we're going to add to this 5 pi over 4, we're going to add 4 pi over 4. So what we're going to get is 9 pi over 4. And then we're going to rotate another 180 degrees counterclockwise, and so that's going to be negative pi, or negative square root of 2, comma, and we're going to add to 9 pi over 4 another 4 pi over 4, which is going to be 13 pi over 4. So that's going to be it for problem number 27. Next, problem 29. Okay, same type of problem, except we have P equal to negative 2 comma 5. So we're going to go ahead and draw out a sketch similar to working out problem number 27. So negative 2, so negative 2, 2 to the left, and 5 up, 2, 3, 4, 5. So negative 2, 5 is going to be located over here. And let me see if I can get a little bit more accurate. So about right here. And so what we have here is a triangle. I'm drawing the hypotenuse now. So we have, in this case, our adjacent side being negative 2 to the left of the y-axis, and our opposite side being 5. And so in this case, our hypotenuse, this diagonal distance here, our hypotenuse is going to be square root of, we're going to have negative 2 squared plus 5 squared. And when we work this out, we're going to get 4 plus 25, or 29. So our answer to our hypotenuse is square root of 29. So for being between 0 and 2 pi, we're going to have put part A right here. So part A, we're going to have square root of 29, comma, what we have to do is find the right angle here. Now, it says approximate exact solution values with a calculator when appropriate. So in this case, unlike problem 27 where we had a known angle, a 45 degree or pi over 4 type angle in radians, we're going to really have to use a calculator to find out what that is. And for that, we're going to find a reference angle right here between the x-axis and this diagonal line. We're going to call that theta. And alpha. So alpha is equal to the inverse tangent of our opposite over our adjacent, which is going to be 5 over -2. So what I'm going to do is, I think I'm going to work in degrees here. I think it's going to be easier to articulate. So I see the calculator is in radians at this point. So I'm going to go to mode and come down to degree. So we've highlighted degree. And so now we're going to get our inverse tangent of 5 over -2. And for that, we get -68.199. We'll call it to the hundredths place. So alpha, we'll say, is equal to -68 point 0.199 degrees. But I'm really more interested in our standard position angle, which is going to be this distance right here. And so what I really want is this theta equal to 180 degrees plus or minus 68.199. So what I'm going to do is add 180 degrees to that. So I get 111.801 degrees. So we'll say theta equals, make sure I get this right, 111.801 degrees. And so we're going to say over here is 111.801 degrees. Okay, so that's going to be one polar coordinate between 0 and 2 pi. And if we add another 180 degrees to that, we're going to have negative square root of 29. And what do we do when we add another 180 degrees? We'll just come over here, plus 180. So we get 291.801 degrees. So that's going to be part A. And we are between theta between 0 and 2 pi. So we are not in radians here. We could convert to radians pretty easily. And I'll just show you how to do it. I'm not going to actually do it, but this one right here, this 291.801, we could multiply this by 180, by pi over 180. So times pi divided by 180. So this would be in radians, 5.093 radians. Or I'll put negative square root of 29, comma 5 radians. I'll just put RAD. Okay, so that would be in radians. Okay, and for part B, we're interested between negative pi and pi, so definitely we'd have that first polar coordinate pair. I'm going to put square root of 29, comma, 111. I'm just going to put that in radians. 111.801 degrees. 111.801. That's going to be times pi. That's going to be right here over 180. And so somehow I got a syntax error here. Okay, yeah, it was that parentheses, 111.801 times pi over 180. So 1.951. Or this time we're going to go toward negative pi. So we're going to go ahead and make this negative square root of 29. And we're going to take that 1.151 and subtract from it pi. So 1.191 subtract pi radians. So we'll put minus pi. So we get negative 1.190 radians. That'd be radians. I'll put RAD. And this one right here, of course, is radians also. And then for part C, which is between 0 and pi over 4, we're going to have our first two values. So we're going to have this one here, square root of 29, comma, and we have 1.951 radians. Okay, and that comes from this 118.801 degrees. And then we're going to have likewise this negative square root of 29, comma, 5.093 radians. And then we're going to rotate another pi radians to go beyond that. So we have square root of 29, comma, and to this angle here, actually the angle of 5.093, we're going to add pi to that, plus pi. We're going to have 8.234 radians. So 8.234 radians. And that's going to be that one right there. Okay, and then the last one, we're going to rotate another. I'm going to just write this down below a little bit. We're going to have yet another pi rotation, that's going to be negative square root of 29. And we're going to take this 8.234 radians and add pi radians to that. So we'll put plus pi radians, and for that we get 11.376 radians. And I think that's the last one we can get before we exceed 4 pi. So that's going to be A through C. So there's some involvement there. Let's go on to next on to a problem. And the next set has to do with, we have an exercise 31 through 34. Use your grapher to match the polar equation with its graph. So we're going to introduce how to do this, how to graph polar equations in our graphing calculator. Now in the past I've done this, I have another video that shows doing this exercise with the TI Inspire calculator. So this is the first time I've shown this using a TI-84 series calculator. So I'm going to graph a couple of these and you'll get, I hope, the idea of how to do this. Now for problem 31, we have R equals 5 cosecant theta. Well, if we look at our calculator, at the calculator plate here on the left, I'm looking for a cosecant key, which would be CSC. I do not see it. But what I do know is that cosecant theta is the reciprocal of sine theta. So it equals 1 over sine theta. So we're going to use this to good effect and rewrite this equation here as, instead of 5 cosecant theta, we're going to write this as 5 over sine theta. So that's how we're going to graph problem 31 to see what matches here. And so we go to the calculator and I go to y equals, and we don't see an R equals equation. So to define that, we go to mode and we go down to where it says function, and we go over here to polar, highlight it. So we're graphing polar equations. We go to quit and we go to the y key and we see the, there we see it. We see R1 equals. So we're going to put 5 over sine theta. So we have 5 over sine theta, which again is equivalent to 5 cosecant theta. And we press theta there, like the X key, but it gives us theta in this case. And we graph, and this is what we see. Nothing. Let's go to window. Well, our window is right. It looks like everything should be right here. Not quite. Look at what our angle is in. It's in degrees. We're going to need to change that to radians. So I go over here. There's a lot of troubleshooting involved dropping these. So now we graph, and we see a horizontal line where f of x equals 5. So that's what the graph looks like, and that's going to be graph B. So I'm going to put B next to this right here. So that would be that graph. And then I'm going to go to 33, R equals 4 cosine 3 theta. So we go, have a little easier time graphing this, go to y equals. Clear this off. So cosine, and we're going to put in 3 theta right here like this. And graph, this is what we get. So it's a pretty tight window here. So I can go ahead and make that a little tighter by going to maybe x minimum of like -2, maximum of 2, y minimum of -2, y maximum of 2. So we get this for a graph. So it's looks like one of the petals is pointed straight toward the x-axis with like a distance of 1. So, but I drew that wrong. It should be 4 cosine 3 theta, right? Yeah, so that was not correct. So let's fix that. We'll put in 4 cosine 3 theta, but I'm going to have to change my window again to be able to see that sufficiently. So I'll put -5 to 5. -5 to 5 should be still apparent what it is. So that's going to be it, which is going to be graph C. And you should be able to do, as a calculator exercises, 32 and 34. So that's about it. I hope this has been helpful to you. Good luck, and thanks for viewing.